Have you ever looked behind a wall in your home to observe the maze of wires leading to outlets and light fixtures? Perhaps you've noticed the many wires in the engine of a car or truck. If you've ever seen the inside of a radio or computer, you may have seen wires there connected to various devices. And if you've ever taken a walk around your neighborhood or a drive, chances are you've seen electrical poles supporting long strands of wires. These are all examples of electric circuits. Electric circuits are very important to our daily lives. Every time you flip a light switch, turn on a computer, or watch television, you're using electric circuits. During the next few minutes, we're going to take a look at some of the characteristics and types of electric circuits, while exploring how electricity moves through them. If you've ever accidentally touched an electric fence surrounding livestock, you know from the pain you experienced that the wire contained electric current. What exactly is electric current? Simply put, electric current is the flow of electric charges through a material. As you know, protons and electrons possess a property called electric charge. When charges flow through a wire or another material, an electric current is created. Electric current involves a continuous flow of charges, much like this stream is a continuous flow of water. But what makes electric charges move? In order to make electric charges move, you need a device which produces energy, such as an electric generator or a battery, seen here. You observe. What happens when the wires are connected to the terminals on this battery? As you can see in the graphic, electric charges move from one battery terminal through the wire to the other battery terminal. This happens because something called an electric potential difference was created by the battery. Electric potential difference is the amount of work required to move a charge between 2 points. The unit of potential difference, or the energy per unit charge, is the volt. The greater the electric potential difference, the greater the current. This 6-volt battery, for example, creates a greater electric potential difference than this 1.5-volt battery. Remember, batteries are just one way electric potential difference and electric current are produced. Let's now take a closer look at electric circuits. The wiring in your house, as well as the batteries and light bulb in this lantern, form what are called electric circuits. An electric circuit is a complete closed path through which electric charges flow. Let's take a look at the parts of a circuit. An electric circuit consists of a source of energy, a load, also referred to as resistance, and a switch. In this circuit, the battery is the source of energy. The plastic-coated strands contain metal wires. This device is the switch, and the light bulb is the resistance or load. You observe. Why isn't the light bulb lit in this circuit? This light bulb is not lit because the switch is open. This circuit is called an open circuit, and current is not flowing. The switch has to be closed to make a complete closed circuit. Now current is flowing through the closed circuit. There are two major types of circuits: series circuits and parallel circuits. The type of circuit depends on how the parts of the circuits are arranged. This is a series circuit. Notice how all the parts of the circuits are connected one after another. There's only one path for the current to travel. You predict. What will happen to the circuit if this wire is disconnected from this bulb? As you can see, not just the bulb to which the wire was connected went out, but all the bulbs went out. This is a big disadvantage of series circuits. If there is a break anywhere in the circuit, the entire circuit fails to work. Fortunately, another type of circuit solves this problem. When a light goes out in this chandelier, the other bulbs don't go out. When a light in this chain of lights goes out, all the rest of the lights stay lit. And when a light goes out in this room, the rest of the lights in the room remain operable. In these examples, the lights are wired in parallel circuits. In a parallel circuit, different parts of the circuit are on separate branches. Notice how there are a lot more wires in a parallel circuit than in a series circuit. The separate branches allow the current to take several paths in the circuit. In this parallel circuit, if one bulb goes out, the other bulbs stay lit. The circuits in most buildings, including your home, are wired in parallel. Let's now take a closer look at some of the other features of circuits in your home. Every year, hundreds of fires occur in buildings due to faulty wires, mostly old wiring. Often, these fires are due to short circuits. A short circuit is an unintended path connecting one part of a circuit with another. When a short circuit occurs in wires, the wires can overheat and start a fire. One safety feature found in appliances such as refrigerators and microwaves is a third prong on the plug. This prong is called the ground prong. The third ground prong is connected to a wire in the cable which, when plugged into a socket, is connected to a ground which carries no current. The ground plug is designed to protect against short circuits. If a short circuit occurs, the charge could flow into the shell of the appliance, and the appliance might shock anyone touching it. Fuses and circuit breakers are other safety mechanisms in your home. If you were to run a microwave, a blender, and a toaster all at the same time, these appliances may suddenly stop working. You decide. Why did the appliances turn off? The reason the appliances went off is because they overloaded the circuit, causing it to overheat. This small mechanism, called a fuse, caused the current to stop in the circuit. Fuses are safety mechanisms which shut off electric current when the current gets too hot. Inside a fuse is a piece of thin metal which melts when too much current flows through it. This fuse has already melted. Once a fuse is melted, it needs to be replaced with a new one. Older buildings typically have fuses. Modern buildings tend to have circuit breakers instead of fuses. This is a breaker box containing several breakers. When a circuit becomes overloaded, the circuit breaker flips and the current is shut off. Circuit breakers are easier to use than fuses because they just need to be flipped back on if they go out. During the past few minutes, we've explored some of the fascinating characteristics of electric circuits. The program began by describing electric current as the flow of electric charges through a material. The basics of how electric current is produced were explained. Components common in electric circuits were highlighted, including a source of energy, a resistance, wires, and a switch. Open and closed circuits were also compared. The arrangement and characteristics of both series circuits and parallel circuits were demonstrated. Last, some of the aspects of household circuits were discussed, including fuses, breakers, and ground prongs. So, the next time you put batteries into a flashlight, flip on a switch, or put lights on a tree, think about some of the things we just discussed. You just might think about electric circuits a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. Electric is the flow of electric charges. Number 2. The light bulb in this circuit is the Number 3. The bulb is not lit because the circuit is Number 4. This is a circuit. And number 5. A circuit prevents circuits from getting dangerously hot.